Okay, think about this. When an engineer is gearing up to build a new water system or some kind of climate resilient structure for a community, what's their most important tool? Is it their grasp of physics or fluid dynamics? Or just maybe, could it be something else entirely? I mean, what happens when our best, most brilliant technical solutions run smack into the messy, unpredictable reality of human culture and history? For the longest time, the gold standard for working with different communities was this idea of cultural competence. The thinking was pretty straightforward. Just learn the facts about a culture and you'll be competent enough to work there. But as engineering projects get more and more tangled up with solving huge global challenges, we're talking poverty, climate change, we've got to ask a pretty serious question. Is just being competent really going to cut it anymore? And this slide right here, it shows you the huge shift in thinking we're talking about. The old way, cultural competence, kind of treated culture like it was a textbook you could just memorize. But this new framework, which comes out of the research of Zimba, is called cultural complexity thinking, or CCT for short. It completely flips the script. It says culture isn't a list of facts to be known, but a living, breathing, dynamic system that engineers have to learn to navigate. So, first things first, let's really dig into why that old model of just being culturally competent so often falls flat, especially when you're dealing with the kinds of messy, complex problems that modern engineers are being asked to solve. Here's the real problem with the old way. A simple checklist of cultural do's and don'ts completely misses the bigger picture. It just doesn't factor in the deep, complicated history of social and economic inequality that shapes how community actually works. You see, an engineer can't just parachute in with the technical solution without understanding the web of power, justice, and history that's already on the ground. And that's exactly where cultural complexity thinking, CCT, enters the picture. It gives engineers a much stronger, much more realistic way to work within these complex social landscapes. Okay, so what is CCT really? Well, at its heart, it's basically systems thinking, something engineers are already familiar with, but applied to culture. And even though it comes from the world of social work, the ideas are incredibly powerful for engineers. It asks you to stop seeing the world as a series of simple A plus B equals C problems, and instead see it as a web of interconnected, dynamic systems, where a little change over here can have huge, unexpected effects way over there. This quote just nails it, doesn't it? When an engineer is tackling something like sanitation or food security or climate change, they're not just solving a technical problem. No way. They're stepping into a system of organized complexity where every single piece is connected to everything else. You just can't fix one part in a vacuum. So the big question is, how does an engineer actually start thinking this way? Well, CCT isn't just some abstract theory. It can actually be broken down into a few core practical ideas that really become a new kind of toolkit. This new toolkit really has three main parts. First, see the web. You got to recognize that you can't solve a water problem without also thinking about the local economy and the environment. Second, embrace unpredictability. You have to accept that human systems are always changing, so a super rigid plan is basically designed to fail. And third, and this might be the most important one, value local knowledge. The people in the community, they're the real experts in their own lives. Their insights aren't just nice to have, they're absolutely essential if a project is going to succeed. Okay, so that's the theory. But what does this actually look like in the real world, on an actual project? Let's take this CCT framework and apply it to some of the UN's Sustainable Development Goals, the SDGs, and see how it totally changes an engineer's approach. Let's start with a big one, a classic engineering challenge, SDG 6, making sure everyone has access to clean water and sanitation. We're going to see how this plays out in a place like South Africa. Just look at the difference here. It's like night and day, right? The traditional approach sees a technical infrastructure problem to be solved, but the CCT-informed approach, it sees a human rights issue. So instead of just dropping in some new technology, the engineer's job expands. Now they're leading conversations with the community, with schools, with families. They understand that a new water pump isn't just about hydrology. It's about public health. It's about making sure girls can go to school. It's about gender equality. It's a total reframing of the problem itself. All right, let's tackle an even bigger one now. SDG 13, climate action. I mean, this is one of the defining challenges for the next generation of engineers, for sure. And again, you can see just how massive this shift in thinking really is. A traditional approach might just bring in some universal one-size-fits-all tech solution, like a certain kind of seawall. But a CCT approach? It starts by asking, hey, what if the local community's known for centuries about how to manage their environment? It gets that climate action isn't some abstract goal about global temperatures. For the people living there, it's about protecting their jobs, their homes, and making sure they have food on the table. So what does all of this add up to? Well, it's pointing to a total redefinition of what it even means to be an engineer in today's world. CCT isn't just some new tool to add to the toolbox. It's a whole new mandate for the entire profession. And this new mandate, this new way of thinking, comes with 4 really critical contributions that engineers are uniquely positioned to make. I mean, this completely changes the job description, doesn't it? It's not just about top-down implementation anymore. It's about strengthening a community's own ability to solve problems. It's not just about solving a technical puzzle. It's about being an advocate for social justice. And it's about actively protecting the rights and the incredible knowledge of the communities you're serving. This is the new blueprint. At the end of the day, there's one really big takeaway here. If engineers are going to meet the massive challenges of the 21st century, then the way we train them has got to change. Engineering schools and professional standards, they have to evolve. They need to weave the sustainable development goals and cultural complexity thinking right into their core curriculum, not just treat it as some optional add-on. And that leaves us with one final question, a question for every single engineer or future engineer out there. What will your next project build? Will it just be a bridge or a dam or a power grid? Or will it be something more? Will it build resilience? Will it build justice? And will it build a more sustainable partnership between our technology and our humanity?